Hi guys. So today we're going to be going over some 6.2 key facts. So 6.2 is trigonometry of right triangles. So when we're doing this lesson, one of the main components that's going to come up often in trigonometry is the Pythagorean theorem. And so typically we use the Pythagorean formula or theorem to find the missing side lengths. So we have A, B, and C. Sometimes you'll see it as X, Y, and R, but for now, we'll just say A, B, and C. So C will always be the hypotenuse, which I mentioned here. And the formula itself is actually A squared plus B squared is equal to C squared. So you would need two of the side lengths, and then depending on what you have, you can solve for a missing side using this formula as long as it is a right triangle. Just remember, A and B can be swapped, but C will always be the hypotenuse, which is the angle opposite from the 90 degree, and it is the longest diagonal side. It's always that. All right, so let's get into some definitions of trigonomic functions. And so this is pretty much is what is going to define trigonometry, our basic things. So just to start, we have sine, cosine, and tangent. So sine can be determined as, or the equation for sine is opposite over hypotenuse. And when I'm saying opposite over hypotenuse and this whole thing, I'm referring to the sides of the triangles. The sides of the triangle in reference to the angle. So if we look right here, our angle is here. And so if we're looking for the opposite side, that is going to be the angle pretty much just straightly across from that. The adjacent side is going to be the side that is directly next to, or what adjacent is directly next to the angle. However, don't want to confuse it with the hypotenuse. Remember, the hypotenuse is always that long diagonal side, so it can't be the adjacent side. Though it looks adjacent, it's not adjacent. And so same thing over here. It just depends on where our angle is where our opposite and adjacent sides are. So since our theta is up here, our opposite side is down here. And then our adjacent side is right here because that's next to our angle, and then our diagonal side is still the hypotenuse. So sine can be written as opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And so these are the main three. And then we get into our reciprocals. So cosecant, secant, and cotangent. So cosecant is 1 over sine. So you can just flip our sine function here, and we get hypotenuse over opposite. And then secant is the reciprocal of cosine. So if you flip cosine, you get hypotenuse over adjacent. And then tangent or cotangent is the reciprocal of tangent. So if you flip that here, we get adjacent over opposite. And so those are our trigonomic functions. And also, you might have learned a fun phrase in school, and if not, there's SOHCAHTOA, and that's how you can remember sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA, it's a little trick you can learn. All right, and also I'll just keep a note that these are very important to memorize because this will come up forever. These will not go away. These are very, very important to memorize, especially these three. And as long as you know which ones are the reciprocals of what, as long as you know these, you can just flip it. You don't have to inherently memorize, just memorize knowing which ones are the reciprocals. All right, so reference triangles. So reference triangles are very important in trig, and these are two sets of triangles that are actually going to be helpful in allowing you to solve trigonomic equations or functions without using your calculator. So we first have our 45, 45, 90 degree reference triangle. So basically we have our 90 degree in the corner, we have our 45 and our 45 in the other two sets. And so what this basically is just saying is that a 45, 90 degree triangle is always going to have a side length of 1, 1, and then a hypotenuse of square root 2. It'll always stay the same. And then if we're using what we just learned, this is how you would put SOHCAHTOA into action. So sine of 45 degrees. Remember that sine is opposite over hypotenuse. So let's say we're referencing this right here. Opposite of 45 degrees is our 1, and then our hypotenuse is square root 2. And so that's how we get this. And also sometimes you might see it written as square root 2 over 2, and that is just a simplified version. Same thing with cosine. Remember, cosine is adjacent over hypotenuse. So this would be our adjacent side, this one right here. And then our hypotenuse is still 2. And then our tangent, 45, if we remember, tangent is opposite over adjacent. So our opposite side is 1, and our adjacent side is also 1. So that's how we get this. All right. Oh, sorry, just a note, this also works in radian mode. So 45 degrees is equal to pi over 4. So this does work in radian mode as well. Okay, on to our second reference triangle. It is our 30, 60, 90 degree triangle. And so the way this works, we still have our 90 degree angle, and then in one side is to 30 and one side is to 60. And it doesn't matter where you place the 30 and 60, as long as you have to remember that the sides do correspond to where the angle is. And what I mean by that, and the way I typically like to memorize this triangle, is that the square root 3 always has to be adjacent to the 30 degree. So I can just show you what I mean. For example, if you were to draw this out right here, you can put 30 degrees there and 60 degrees here, but then the square root 3 is here, here, and then the 2 will always be the hypotenuse. So basically what I'm just showing with that is that the 1 is always adjacent to the 60 degree, the 30 degree always has an adjacent square root 3 side, and then 2 is always the hypotenuse, and you can kind of see that with here. Square root 3 is always adjacent to the 30 degree, and the 1 is always adjacent to the 60 degree. So if we were to solve it, like do say sine of 30 degrees, remember sine is opposite over hypotenuse. So opposite is 1, where hypotenuse is 2. So we get 1/2. Same thing with our cosine up here of 60 degrees. Remember, cosine is adjacent, so this is our adjacent side. And then our hypotenuse is 2 because it's on the long diagonal side. And then same thing for the rest of all of these, same exact things, just with different trig functions. So let me just give some calculator tips because the use of calculators will come up a bit. So just some important notes. In this class, you should be using the TI-30XA. And so for the TI-30XA on the top, there should be a DRG button, and this is how you change the mode of your calculator. So on your screen, when you press it, it'll show a degree on the screen, it'll show a rad on the screen. That's exactly what it looks like. And there's also another one, I believe it's grad, but that doesn't matter for our class. And so if you're doing a question that's in degrees, so they're giving you angles in degrees, you need to make sure it says degree mode on your screen because that's how you know you can solve it correctly. Same thing if your question is in radian mode, which remember is like our pies, then it needs to say rad on your screen. So like, let's do an example of how to type in a question like this. If it was to give you sine of 25 degrees, how you would actually solve this is that you would type in 25 first on your calculator. So type in 25 into the calculator, and then you would press the sine button on your calculator. In this case, make sure you're in degree mode. And then once you press that, it should give you an answer. And then the reciprocal, here's just the order to press. So I'll just do an example of cosecant. So you would want to type in your angle first, just whatever this is. It could be 25, it could be 50, it could be basically anything. So you would type in your angle first, and then making sure you're in the right mode, depending on what it is, and then press sine, and then press the 1 over x button. And that's how you would solve for cosecant. The reason why we do that is if we remember, up here, sine is the reciprocal of cosecant. So that's basically just what we're doing here. Same thing with secant and cotangent. So for secant, you would press the cosine button and then the 1 over x button. And then for cotangent, you would press the tangent button and then the 1 over x button. And that's how you would solve those kinds of problems if given something that might look like this on your calculator. Alrighty, this is about the bulk of 6.2. I hope this helps. If you have any questions, feel free to email me. Thanks.